Look at this option. What is this?
Sail unit.
Sail unit, no? And look, the input shaft of the transmission engage with the flex plate. I don't have the flex plate over there, but the flex plate over there and the crankshaft. Always, always. What type of engine can I install here?
Anything. Electric,
Diesel, gasoline, electric,
anything.
propane.
Yeah, whatever you want.
I have a boat, a catamaran with a couple of those units. Can I convert that catamaran in electric?
Of course, yeah.
Of course. I am going to calculate the engine here,
Sure.
the motor,
Yeah.
according with the torque produced for that. I select the motor, electric motor, AC or DC. I install my motor here. I calculate the inverter appropriated for that motor. And with the inverter, I calculate the battery bank. And with the battery bank, I calculate the capacity of the solar panel. Or generator. Or both of them.
It's called a stern drive? This is the stern drive?
No.
Or sail drive, I mean.
Sail drive. Sail drive. Let me explain something that is very, very important.
And a sail.
What is the most difficult part when you try to convert this original design with a diesel engine or gasoline engine here into electric or hybrid? What is the most difficult part?
Getting the
How I engage the motor, the new electric motor here in the actual lower unit or transmission.
clutch plate.
Okay, one element that you need to take in consideration is the original flex plate that I have here. That's important. And other important is this bell housing. Because in this bell housing was bolted the original engine. Yes or not?
Yeah.
Okay, I need create in aluminum or steel one plate that engage here in the motor and
Step up.
here on the transmission to put the motor in that flange. I need design a flange with the holes for this and the holes for this. And additionally, in that flange, I am going to bolt it in this flange. You need that one.
Yeah.
You need that one. That one enter in the splines of the transmissions. Yes or not?
Yeah.
But should be attached to this shaft. I need create a coupling that enter here and be bolted here. One coupling that enter in this shaft and externally be bolted here. And this one in this enter here. Okay, you need create the flange for this shaft and this together with this. And you need create another flange for those holes and those holes. Two flanges.
No.
You need design the flanges, do the drawing, send to the machine shop, select the material. Don't forget aluminum grade, marine grade, or a stainless steel marine grade. Both of them.
Or just look online.
Can you repeat how many elements you need? Two. One flange entering here
For the
and
flex plate.
attach here for the flex plate. And other flange entering here and bolted here
For the housing.
for the housing. That's it.
But then you
That's
still
it.
need, you still need a motor mount.
Of course.
Yeah.
And the bracket for the motor mount. The bracket for the motor mount. But this is the less difficult part, because in aluminum you fabricate the brackets release on the actual stringers. Pam pam pam. And don't forget, in the motor mount you have in the shaft of the motor mount 2 nuts to adjust the angle, the inclination. Okay, of course, you calculate the electric motor according with the torque produced for this engine. Now with the electric motor, you fabricate 2 flanges. One flange for the shaft and the flex plate, and other flange from the housing of the electric motor with the bell housing of the transmission. And bingo, finito. The next question is how, okay, with the motor, I am going to administrate the RPMs. How I administrate forward and reverse. This is the original control for forward, neutral, and reverse. And originally, this is with cable in the console. I am going to continue exactly with the same mechanisms. The same mechanisms for the drive. And what about the mechanism for the RPMs? I am going to keep the same cable with the same, but here in the motor, enter in the frequency driver.
Frequency driver or
Frequency driver because it's AC mode.
AC mode.
Bingo, finito.